Okay, so Narc is basically a very pseudo-simple program that's meant to run on only Windows computers that can work with the Canvas API to sort of build a data set based on testing data from a specific quiz and actually use that data, look at trends in it, and find outliers that will then be labeled as potential cheaters. And this works through a few different methods. Number one, mainly it was developed with the idea of an autoencoder, which is a type of neural network which maps a function basically to describe the data that is inputted into it. So what that means is instead of taking an x and mapping it to a y, it takes an x and maps it to an x. And the benefit of that is if we give it data that is not at all similar to the data it's already seen, or testing data that's very anomalous, it'll output a very high error. It won't be able to reconstruct that data. And that's pretty cool because it allows us to separate anomalies from normal testing data, and then from that we can even separate the anomalies into two different classes. So for example, if we separated a cheater and maybe someone who's just really good at taking that specific test, we could then use another classification system that's unsupervised called k-means, which will make two distinct classes from a given data set. So Narc is an open source project. It's made entirely in Python, and it can be downloaded from this release tab on the GitHub page, which will be linked in the description. And you can either download the RAR file, which is just a smaller version of the zip file, or if you don't have a archive manager that supports RAR format, you can just get the zip file and have a, slightly bigger file. Either way, it doesn't really matter. So when you first download Narc, it's going to look something like this. It's not going to quite look like with these books and everything, that's just WinRAR being WinRAR, but you'll have a zip file. It'll look like a normal folder. What you're going to want to do is you're going to want to extract that here, and that'll take a second since it is a decently sized archive. So once you finish extracting, you're going to have the three files here, the README, which is basically a written tutorial of what I'm saying now, sort of. It's a little less good. You'll have the license, which is just a standard MIT license. It basically does nothing except make it look more professional. And then you've got the actual Narc folder itself that contains the program. So in here is a bunch of precompiled code, which is just libraries that Narc needs to function, and inside it is also the actual executable for the file. So since this isn't a program that comes with an installer, you're just going to have this executable wherever you put it. I've personally put it in my documents. However, if you want to just make it easier to access, you can always pin it to your taskbar, and it'll stay there even when you've closed it. So when you open Narc, the first screen you're going to see is this, and this is just the license agreement. Once again, it does nothing except say you don't have any warranty with this, but this also isn't something that needs warranty because it's software that just uses the Canvas API and nothing else. So there's nothing to worry about there except a decline. You're gonna close the program, except it's going to create a confirmation that you accepted it and everything, and everything will be fine. Okay, so then you get this menu here, and this menu is going to take a little bit of explaining. So the API key is just something that allows the program to interface with the Canvas API, and that literally means nothing for you other than you have to come to Canvas, you have to go to your account here, go to settings, and then scroll down where it says approved integrations, third-party applications that will access the Canvas site on your behalf. You create a new access token. You can just name it whatever. It doesn't actually matter. I personally wouldn't put an expire date on it, but if you're a security person, then maybe you would want to, or someone who's paranoid about security or whatnot. And then you want to copy this token right here. Do not click X before you copy this. You'll never be able to see this full token again. And then so you close out of that, or you can leave it open either way, and you can paste it here, and you've got your token. And then your URL is just the beginning part for the before the instructor in your Canvas thing. So for me, it's in CCS. For something like Stanford, it would be Stanford. Things like that. And then this third option, regular SSL or Zscaler or similar network security, that it can basically be universally ignored. Essentially, that was made for a poorly configured network and is no longer super relevant. It is there just in case there are people on a poorly configured network, but I highly recommend not touching it because it will leave you open to lots of network attacks. Just leave it at regular SSL, don't change it. And so you confirm that information. Narc will do a quick check in the background to make sure that the information works. There won't be any output here, but I promise it did. And so then you will have a menu that's kind of small, but you've got a settings button and a course selection button. So essentially, to do a proof of concept, I'm going to go ahead and look at a AP Euro history quiz that we did, and we'll look at the results from that. So the settings, you can always change your API key in case you maybe have two Canvas accounts. For example, if you have a sort of, on-site classroom Canvas, and maybe you're also an online teacher part-time or something, you can have the two accounts linked to this. You have to change them between each run, but of course you can still have them. And then the separation you want to use. So that can be an autoencoder, basic anomaly, or no exceptions. So the difference between these are somewhat minimal, except for the no exceptions. Autoencoder and basic anomaly are very similar in what they do. So essentially the autoencoder uses the neural network I talked about earlier to do an initial separation, and then from those anomalies, separate those into two groups. And essentially the intuition behind that is that there's going to be groups of cheaters and groups of people who are either very high or very low performing students who didn't cheat. And then the basic anomaly is going to not use a neural network, but use a one-class support vector machine, which is another type of unclassified classification, or unsupervised classification, sorry. And that will be before another unsupervised classification happens, and it will do it very close to the same thing, except it will be far more consistent than the actual autoencoder. The autoencoder tends to learn data differently on each run, which can be a problem, but in the testing that I've done on the data that I have, it hasn't actually caused too much variance in the actual score of accuracy, which is the F1 score in this case, but it is there in case you are concerned about that. And then no exceptions is if you are absolutely anyone who leaves the page at all during a test, they are a cheater. They are going to just be classified as a cheater, and you can see how many times they left the page. Simple as that. You don't believe they left the page to change music. You don't believe they accidentally clicked off the page. They left the page. They are a cheater. Things like that. And you don't believe Canvas could have messed up, that sort of thing. So for this one, we'll use the autoencoder, and then we'll look at it with no exceptions just to show what that looks like. So we can confirm our settings, and it'll save it. It'll get our courses again, and we'll go to our AP European History, and we'll select the quiz. And here it just builds the data set. So initially, the settings are gonna just have the number of the time it took, the average time between questions, and then the amount of times the user left the page during the test. And then it obviously formats with names. So you can see, normally the Canvas API comes back in student ID or Canvas student ID instead of name, so it has to do that. And then if you press Control and F12 on this one, you can see a developer menu. Now this one, obviously, as you can see in right, you probably don't want to touch any of this. This is just settings for the autoencoder. So I won't go into detail about what these do, but essentially they are not super important. These I've found to be the optimal settings, but it may be that on different sets of data, the optimal settings change. On perhaps larger sets of data outside of the limited 20 people maybe that I've tried, it could be that you need different settings. Maybe 30 or 40 will adjust that. simply put that in there just in case that is the case. So we had the average question time, the total time taken, and the page leaves. So this is essentially choosing what features we want in our data set. You could also do the number of questions changed, the user scores, and the difficulty index. The reason we don't do those, or at least that I don't do those, is I found those actually don't do a great job of indicating cheaters, the difficulty index being the best out of those unchecked features. Funnily enough, user scores usually is the least good indicator because a lot of cheaters will only cheat on one question and then still bomb the rest of the test. So typically the page leaves, time taken, and average question time seem to be the best way to describe cheaters. So if we confirm, it'll go ahead and check and see if that's what the data set that we already built beforehand, if that's the same thing that we just selected. It is, so it doesn't rebuild it. And so then if we click Start Separation Process, it'll start the autoencoder. And this will take a while because it is a neural network and it does have to train on the data. So I'll just let that run. Okay, so once it finishes, it actually starts a clustering algorithm. Now, I've had to block out the names to preserve identities, but as you can see right here towards the bottom, the test threshold, that's actually how low the error was on average. And so anything that's above that error, it's going to flag as an anomaly. And then any anomalies are going to be run through a clustering unsupervised clustering algorithm, k-means, to determine whether they belong in a cheater category or whether they belong in a not cheater category. Okay, so what you're seeing here, there were some people who were pre-flagged as cheaters here at the bottom. Once again, the names are blocked out because I don't want to publicly call anyone out here because there is some suspicious stuff. So the ones here, these checks at the bottom, these are people who left the page so many times that you can't reasonably say that they were leaving because of something else, because it's more than, I believe, 70 or so % of the questions is the equivalent of how many times they left the page. So it seems like they cheated on basically most tests. Now, what happens if I don't actually pre-flag these people is the anomalies get skewed so highly towards these people who cheated on the majority of the test that the people who cheated on some of the test, or like only a few questions, aren't actually flagged because it's the anomalies become the people who were just like the extreme cheaters. So the pre-flagging removes this problem, and also really it classifies more cheaters. It finds the people who are these extreme cheaters, and they're guaranteed to be cheaters. So just go ahead, just put them in their own pile and look at the rest of the data set, see if there's anything else here. So this up here, there was only 2 anomalies flagged this time. So we've got one, these two, the ADL and the OD is opposite and assigned distance. So the k-means, basically, if you think about it on a 2D plane where you've got your x-axis and y-axis, you can think of this as this person's point. They are 0 distance from their assigned point, which just means they are, their assigned points, and the opposite distance from the center of the other class, which is this person over here. So the assigned distance for this person is 0. Obviously, they're 3 from each other. So this is actually 3-dimensional data, because if you'll remember, we had 3 features to describe our set, but it can be intuitively thought of on a 2D plane. It doesn't really matter how you think about it. And then you've got this button here, View Data, and once again, I'm going to, the names, but essentially it just gives you your data set. You can see the original data set, and you can sort of use that to see if you want to go investigate anyone any further, maybe that it didn't flag, or that it did flag and it doesn't look like they actually cheated, things like that. So you've got access to the original data set, very nice, neat, and organized. Okay, great. So now let's actually take a look at what happens when we just do no exceptions. Okay, I've restarted the program here, and as we did before, we'll go into settings, and we can click here and click no exceptions. So this will take anyone who left the page and say, okay, this person left the page, this person's a cheater. Guaranteed, done, no question about it, things like that. And then obviously, if you do that, you can see how many times I left the page, things like that. So this time, let's take a look at a psychology practice test that I did, AP Psychology, and we'll look at how many times people left the page on that one. So if we click Select Quiz, it obviously has the first build data set, which is just a one-dimensional vector of the page leaves with the names. And now that the dataset is built, you still actually have the access to these options. Obviously, the autoencoder settings don't do anything here, but if we wanted to, we could actually, just for a proof of concept, get the entire everything, all the data set, and we can actually build all that. It'll take a moment to build, obviously, because we're building like a 6-dimensional data set. So, okay, and now if we click Start Separation Process, it's just going to instantly, we got it. So we actually have all the names and all the page leaves here. So what's interesting about this is you can see that some people have page leaves of 1. Which is just one time. And if you look at the original Canvas data, sometimes those page leaves are at the end of a test, where it's like the last thing they did was leave the page. So perhaps they submitted it and then clicked off after they submitted it. So things like that can be sort of anomalous with Canvas data. So it's good that you can, of course, see the page leaves, and anyone who does have very low page leaves is something that you may want to look into further than just saying, okay, well, this person definitely cheated. But something like page leaves of 15, page leaves of 6, 12, 8. These are very high and very unlikely just to be Canvas messing up. These are things that are definitely worth looking into. And that's just about it for Narc. Obviously, you can always select another quiz from one quiz, and you've got a module. I know I didn't show it off, but you've got a module selector here, but obviously these only have one module. But that's it for Narc. It is a cheat detection program, and that's what it does. It finds people who left the page, or it finds people through finding anomalies. This was developed on top of sklearn and TensorFlow libraries, as well as the tkinter built-in Python GUI library, and was compiled with PyInstaller. And the works it is based off of are listed on the GitHub page. So thank you for obviously viewing this video. Perhaps maybe you even downloaded Narc and you found this helpful. Thank you.